All right, everyone, we are back, and let's get into problem 4, don't be phased. So, if we're looking at our phases, we're going to have mg plus this phase here, mg plus liquid right there. This will be liquid plus this phase right here. This little tiny phase here will be liquid plus this phase right here, this phase plus this phase in here, and you kind of get the picture. Liquid plus this little phase right here, this phase plus this phase, this phase plus this phase, this phase plus this phase, this phase plus liquid right here. Let's scroll over. This phase plus alpha, this phase, or this phase plus delta, excuse me. Delta plus this phase here. This phase plus alpha here. This phase, mg and d plus beta right here. Beta plus alpha right here. Beta plus liquid in here. Liquid plus this phase again up there. And that's it. So those are all of our phases, or two-phase regions. So labeling our phase diagram. Now, I want to do all the congruent melting points. Here, 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 and here. So those are all our congruent melting points. Let's look at our invariant points. So we are going to have a eutectic here, peritectic here. There's going to be a peritectic here. There's going to be a eutectic here, another eutectic here. There's also, that's the peritectic here. This single phase to a two-phase solid region, that is a eutectoid. This is solid plus solid to single phase solid, so that is a peritectoid, and this is a eutectic. So those are all of our invariant points. So make sure that we label all those correctly. Consider composition at 21 ND and was it 600? So we're looking at something like this. So we have two phases in this region. We have some composition in the liquid, some composition in Mg3 and D. So let's see what the question is asking us. So we said the phases. What are the components? The components are Mg and Nd. So those are the components. What's the composition and fraction of the material in this phases? So the composition, the liquid, is going to be, let's just call it 8. Composition in here is about 25. If I want to do the fraction of my liquid, it's going to be equal to 25 minus 8 over, let's see, for liquid, we go from 25 minus 20. And the fraction that's in my Mg3 and D is going to be equal to 25 minus 8 over 20 minus 8, because I'm going to run away to that liquid phase. Excellent. So composition, what are the chemical potentials? They must be equal. Chemical potential of my liquid must be equal to chemical potential of my Mg3 and D. Good, good, good. Draw the free energy curves for 700. All right, let's get to it. So that is my diagram here. So if I look at it, free energy versus X, I'm entering a two-phase region here, another two-phase region here, another two-phase region here, another two-phase region here, and then another two-phase single-phase region here, and then, all right, and then here we go. Okay, so here I'm beta, so this is my only single-phase region. So I'm going to say I'm single-phase, also liquid here, and then I have a common tangent, because I'm just going two-phase, 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 until I hit there. So I'm going to have my liquid come in, single phase here, and then it's going to just jut out. So this is my liquid right there. The next phase that I touch is going to be this phase here, Mg3. I'm not going to kind of label, I'm just going to say it, because, but that's going to be my Mg3 and D. I'll go ahead. Here, let's do this. That's going to be my Mg3 and D. So that curve is going to go here. It's going to touch, and then it's going to get it out of here. The next phase is this guy, which is going to touch in here. Touch and get out. Excellent. The next phase is going to be my Mgn. touch, get out. And then, let's see here, mg plus that, mg plus, then now I gotta get my beta in here. So my beta is gonna be, let me move gotta move something around here. I need some more colors. Get my cyan. So my beta is gonna be here. Now the beta is gonna go here, touch, kind of hang out, and then I'm gonna have another common tangent that looks like this. I'm gonna touch here, hang out, get out of there. Then I'm also gonna bring in my purple. Purple is gonna be this, and then I'm gonna bring this in over here and then hang out. So there you go. Free energy curves, we know that they are related to chemical potential because my chemical potential is the slope. So my chemical potential is equal to dg dxb, my slope. And excellent, we've got it. That is our problem 4 in exam 1, done. See you next time. Thanks.